How's it going, everybody? And welcome back to our Enterprise Lab, Enterprise Practice Lab specifically, where we're gonna go ahead and take a look at setting up DMVPN between, excuse me, CSR1 and our spokes, just to make sure that everything works the way we expect it to. Now, topologically speaking, what we're essentially going to be doing is using CSR31 as the hub, and then we're going to go through a crypto setup. So I try to mimic this kind of loosely to what I saw in the CCIA lab, to where what they gave you, obviously not exactly, but it's close. So essentially, what you'd see here is phase one. So they're gonna give you the details that they want. I've removed some details from it that I do remember. I can see in my mind's eye what it looked like. It's the flow is correct, but the actual details are different. So, but essentially what this is basically going to do is they have to give you specific enough information, and I am omitting a lot of the specifics. So you'll need in the crypto map, you'll need the variables, and I just said use the weakest ones. Something very simple. Pre-shared key named enterprise, transform set, and this is really no different than how you would if you were going to write a document on how to deploy an IPsec VPN, how you would go about doing it. So I've had to do this a few times for customers when I've had to set something up like this in the past. So, and then we're going to form EIGRP to the spoke sites. Now, one thing I want to talk briefly about before we actually dive into the config is the basic setup of how we're going to be doing this. Now, when we're forming EIGRP adjacencies, one second for me. We're going to be doing EIGRP over DMVPN. It is by far the most commonly deployed protocol over DMVPN. OSPF can be used, BGP can be used. OSPF is not designed to do DMVPN. OSPF is designed to go into big circles. EIGRP, they can do pretty much anything you want. So the way that I have connectivity set up right now is it's OSPF CSR15 9K7 all the way down to my internet and WAN edge. And I'm going to be doing EIGRP, which means I'm going to be able to take routes from OSPF and redistribute them into EIGRP. So it'll basically be EIGRP over here, OSPF right here, and then EIGRP over all of that. So that's essentially what we're going to be doing. So it's going to take a little bit of time to get this stood up and operational, but once we have it there, we're going to be in really good shape. So I'm going to go through and walk you guys through the config of what we're going to be doing. And let me go ahead and pull up secure CRT. And yeah, that's probably gonna, you know what, let me move this over to the top here and move this down. So we'll start on the hub and get the hubs configured. So on CSR31, this is what we're going to go do. I'm actually going to go ahead and get out of the way. And I'm going to go to global config and we do crypto. We have a lot of options for crypto. So this is basically where we're going to start. So I'm going to start off with a crypto map. I'm going to call it phase 1. Phase 1, and then we're going to say ISOCamp. And, no, sorry, never mind. It's going to be the sequence number. So, and then IPsec ISOCamp. Sorry, it's been a minute since I created a VPN. So there we have it. So crypto map will remain disabled until a peer and a valid access list have been configured. Not a problem. So I'm going to go ahead and go underneath here. We're going to do a question mark. Then we have some values that we're going to actually, hold on a sec. That's, sorry, not crypto map. Crypto, I don't know why I said crypto. Crypto ISOCamp. What's the word? What is it that I am so out of crypto, not crypto ISACamp. ISACamp policy. Yeah, okay. I don't know why I did crypto map. Let me do show run pipe section crypto. Okay, no crypto map. We're not going to need a crypto map. Sorry, my mistake. So crypto ISACamp policy 1. And underneath here, we're going to use the weakest options. We're going to come in here. This is supposed to be crypto ISACamp policy. So we're going to type in here, the encryption is going to be triple DES, or sorry, DES. The authentication is going to be a pre-share key. The hash will be MD5, and the group will be 2. I'm not going to use 1, I'll use 2. So do show run. We can get the run pipe section crypto. Okay, so that's the basics. Let's have in crypto crypto ISACamp key. And the key will be, I'll type in enterprise, and I'm going to say address, and I'm just going to put in here all zeros. Essentially what that means is I don't care where the traffic is coming from. And then crypto IPsec transform set, we're going to use phase 2, and we're going to use the weakest options. Again, this is going to be ESP DES, and we'll say ESP MD5. Okay, and then now that I'm under there, we're in good shape. I'm going to go ahead back to here, type of crypto IPsec profile. It's going to be called profile, and we're going to call the transform set of phase 2. So do show run pipe section crypto. There we have it. Everything's been defined up to this point. The next thing to do would be to go create the tunnel. So type interface tunnel 1, and the tunnel mode will be GRE multipoint. The tunnel source, in this case here, will be, I'm going to use gig 4. Actually no, I'll use gig 2. Tunnel source gig 2. That'll be good enough. And then the tunnel is now up because we're doing GRE multipoint. So type in the IP address here. Will be 172.31.255.31/24 mask. And underneath here, we're going to say tunnel. I'm actually not specifying any other key. So beyond that, do show run interface tunnel 1. I'm going to type in IP NHRP, and the mode will be, let's see here. We're going to do map, multicast, dynamic, and then we're going to do IP NHRP authentication. We're going to just use enterprise. Enterprise exceeds 8 characters. ENTRPR. I'll use Cisco 123. Apparently you can't use a really long key. And then, so now that I've got that set up, it's IP NHRP, and then we're going to say next NHS is me. So I'm the next top server. The network ID, in this case here, I'm going to say the network ID is going to be 255. And that's pretty much it. We don't really need a whole lot more to configure any of this stuff. We got the map, the NHS config, the network ID. Those are things that are unique per cloud. But everything else is good. So do show run interface tunnel 1. It's a pretty basic config. Do show IP interface brief. The tunnel is up. So now I type in tunnel protection IPsec profile of profile. So now profile is not defined. Do show run section crypto. Oh. Yeah. IPsec profile. Oh. My bad. We go change that to be a K. Profike. My bad. So ISACamp is on. So, and then actually, let me go do router EIGRP 255. And then, because do show run pipe section EIGRP, router EIGRP 255. And we're going to do network 172.31.255.0, 0.0.0.255. And that's really all we have to do. And then we should be able to form EIGRP adjacencies over that connection. So now that I've done that, let's go ahead and configure CSR 32 for that. And I'll basically be able to do the configuration repetitively. So what I'm going to do is I'm going to jump back over to 31. I'm going to grab all this config right here. I'm going to copy it in a notepad. And that should be sufficient. I'm actually going to change this to be an L. And I'm going to copy that into CSR 32. Copy that in, exit out. And then I'm going to type in interface tunnel 1, tunnel mode GRE multipoint. And we're going to say tunnel source is going to be gig 1. The tunnel should come online now. Then we're going to type in IP NHRP network ID is 255. The IP NHRP authentication Cisco 123. IP NHRP, we're going to say map. And the address of the destination in this case here is going to be, we're going to be looking at, I think it said gig 2, which is going to be 1.17.31. So it's going to be 1.7.17.31.31, and we're going to say the MBA, I'm sorry, this will be the address of the yeah, so this is going to be the, I needed to call the tunnel ID and then the public address. So 172.31.255.31. The MBMA is going to be 1.17.31.31.31. And I can hit the enter key. I'll type in IP NHRP next hop server is going to be 172.31.255.31. And you can do NBMA here if you wanted to, NBMA, and then the address, but this is sufficient right here. And then we're going to say do show run interface tunnel 1. I have everything laid out that I need to. IP address here will be 172.31.255.32/24. And then I'm going to type in tunnel protection IPsec profile will be profile. So ISACamp is on, and then I need to go to router EIGRP 255 and type in network of 172.31.255.0, 0.0.0.255. So let's see if I can form an EIGRP adjacency over the tunnel. And there it is. I have an EIGRP adjacency over it. So if I do show crypto ISA, I have a tunnel up. If I hit the up arrow IPsec SA, I have a tunnel up or encapsulated in GRE. If I do show IP EIGRP neighbor, I have a tunnel. Q count is 1 though. That's a bad sign. I have a problem. So let me see at 31. Okay. Show crypto ISA SA, IPsec SA. We'll do a show IP EIGRP neighbor. No neighbor. Okay, let's see, 32Cs. Yeah, see, this side here isn't seeing it. Let's see here, 32. So normally if I see this, this is normally a problem that I'll see. Yeah, see, it's having a problem resolving it. And it's going to keep flapping. Show interfaces. So we're definitely enabled for it. Let me see if this is... So the quickest way to determine if it's a crypto problem or if it's a DMVPN problem, because they're separate operations, is to take the tunnel protection off. So I'll do this right here on both sides. So then you see this, you know it's not IPsec. So interface tunnel 1, do show run interface tunnel 1. And then I'm going to go ahead and take all of this right here and take it off. The tunnel forms on this side, but not on this side. Okay, so we have a DMVPN problem. Do show run pipe section EIGRP. Can I do ping 172.31.255.32? Okay, I can ping across, which tells me that I know that I have that going. So now we need to troubleshoot DMVPN. So show DMVPN, and we have it's a connection, but we need to look at the detail. So you see that coming up. Show IP EIGRP neighbor. Show run section EIGRP. 31. Do show run section EIGRP. Yeah, it's identical config on both sides. Why is that giving me a hard time? Let's see here. Interface tunnel 1, IP NHRP, map, multicast. Oh, did I not do the map multicast command? I think that's the problem. Let me do show run interface tunnel 1, IP NHRP, map, multicast to, it's going to be 1.17.31.31. Let's see if that fixes it. And okay, I have an adjacency on 31. Do show IP EIGRP neighbor. Okay, that fixed it. So that was the mistake. Every once in a while I forget that. It's been like a few years since I've set up DMVPN, it feels like. So what I'm going to do is I'm going to go back to here in this crypto. I'm going to take this crypto and put it back on both sides. Interface tunnel 1, and take that crypto and put it back on. See if it comes back up. If it comes back up with crypto, I know everything's good. Do show IP EIGRP neighbor. The neighbor's still there. It never even went down. Okay, so what I'm going to do on this side is do show IP interface brief. I'm going to type in router EIGRP 255. I'm going to type in network of 10.32.0 0.0.0.2 and I want to do, see, not 255, I want to do 4.255. No, 3. I want to match on the first 3 subnets, 0, 1, 2, and 3. So if I do that, if I go to CSR31 and I type in do show IP route EIGRP, I see the subnets coming across the tunnel, which is what I want to see. So I know that's working correctly. Okay, so now that I have that figured out, do show run pipe section or interface tunnel 1. Now I need to take this config right here and expand upon it. And I'll take this guy right here and put that right here, but change the IP address to be .33. The source, everything else stays the same. And then the next top server's 31. All that type of stuff stays the same. So once you have a working configuration, it makes it really easy to configure it. So I'm just going to copy and paste this in. Actually, let me go grab the EIGRP config. So do show run section EIGRP. And I'm going to go ahead and paste this in here. But I'm going to say this will be 33. Grab those first few lines. I'm going to copy all this into CSR33. And I'm going to first do ping 1.17.31.31. If I can ping it, that's really what I want to make sure I can do. And I'm going to go ahead and ping, copy and paste this in. ISACamp turns on, the tunnel comes up, and I have an EIGRP adjacency. 31 flapped. And if I do show IP route EIGRP, now I have the 33 networks. Okay, so that's just a wash, rinse, and repeat at this point. So 35, it's going to be the next one. And then I'm going to do a 35 here. Copy and jump onto 35. I'll do a ping to 1.17.31.31.31. Global config, copy and paste. You know what? The source might be tunnel source is gig 1. Okay, so the tunnel's up, but I'm not forming an EIGRP adjacency. So that is going to be the first thing that I want to look at. So I'm looking at 33, 30, 35. Okay, so that's what I want to do. I was able to reach it that way. So how would I troubleshoot this problem? So I can ping it from 35, but let me do a trace to 1.17.31.31 numerically. I'm going to take 23540. Okay, so why am I taking that route? Show IP route. So I have a default route that points me to here, but the drawback is I'm going to take the BGP route because it's more preferred. I have a longer match that way. So how do I fix that problem? Show run interface tunnel 1. I change the source. Tunnel source, instead of being gig 1, I change it to be gig 2. Simple as that. ISACamp will bounce, and then momentarily I should have a EIGRP adjacency over that, because it is a subnet that it can reach, hopefully. Now it'll be a matter of ping 1.17.31.31 sourcing from gig 2. Okay, there it goes. It just took longer, and normally when you see something like this happen where it hangs, it's because you're working through the crypto process. You're having to wait for the interval of crypto to time out. So and if I go over to 31 and I hit the up arrow, let's see here. Did I not do my EIGRP config right? Show IP interface brief. thought I did. Show IP EIGRP interface. Okay, show IP EIGRP topology. They're all there. Why is 31 not learning it? Do show IP EIGRP topology? Infinity. Okay, so that's a problem. So for the 35 subnets, feasible distance is infinity. Let's do a show crypto ISA and show crypto IPsec SA pipe include peers. SA peer. Okay, so 235, 40, 35, good. Let me do PKTS. So I've got packets coming back and forth, which is good. But the routing is not right. Show IP EIGRP topology. So what I'm going to do is on 35, I'm going to bounce the tunnel. Interface tunnel 1, shut it down. Take down the adjacency. And then wait for 31 to notice the adjacency is down, which will take 15 seconds. So neighbor. Okay, the timer expired. Now let me no shut it. Tunnel is up. Adjacency is up. 31 sees it coming in. Still coming in as infinity though. I don't understand why that's coming in as infinity. I'm a bit perplexed on that one, but I'll come back to that here in a minute. I'm not exactly sure why that's giving me a hard time. So what I'll do is pull up Notepad again. I will do basically the same thing on CSR 36. Show IP route. Where am I learning? So that's going to be 236. So show IP interface brief. 236. That'll be gig 3. So I don't have a default route. So so this is one of those things where I have to map it where I know the traffic is going to be. So 236.75 is where I've got a BGP peering. Did I not complete the config on that for the spoke? Form EIGRP, to ISP2. Okay, I did not. So here, show BGP IPv4 unicast summary. I do have peerings to both. Oh no, I don't. I only have one peering. I have a BGP peering to CSR 45 and one to Nexus 9K75. I forgot the one to CSR 40. So I can throw that one in here and get the job done that way. But show run section BGP, did I configure it? I never did. Okay, that's part of the problem. So I'll just update the config in here to be gig 3 of where I'm coming from and make this .36. So let me go ahead and make this .36 as well. Copy that and then jump into 36, go to global config, copy pasta. Tunnels up, go back to 31. 36 is infinity as well. Show IP route EIGRP. I'm only learning 31 and 32 and 33. I'm actually kind of perplexed that I'm not learning And I'd have to dig into this and figure out why that's not coming across. It could be a routing problem, certainly, but unless, wait, actually, hold on a second. Show IP route. Okay, never mind. I see why. So these guys are being learned via BGP because they're BGP peered. That's why. So what's happening is I've got DMVPN and BGP coming both out of 35 and 36, and because BGP is being more preferred, it's setting the infinity bit, even though the values are not. It's learning it via BGP versus EIGRP. Now, that could be a good thing, that could be a bad thing. Now, what I normally would do in this situation is I would set up a second tunnel, but I would source my DMVPN over the DMVPN or the MPLS VPN, so that I'd have, let me go ahead and get out of the way here and basically explain what I'm talking about here. So if we were to come in here and let's say orange is current, move this up a little bit, orange is current DMVPN, right? So I have a DMVPN tunnel to here, I have one to here, I have one to here, and I have one to here, right? Everybody's tracking so far. The thing is, right now, if I switch this over, currently, can I make this a little bit thinner? No, I can't. Currently, actually, let me back this up just a little bit. This would allow me to draw a line and make it orange. So from here to here, from here to here, so on and so forth. But from an operational perspective, I am going this way for DMVPN. I'm learning my routes this way. And then for this path here, I'm actually coming in this way and learning the routes via MPLS. Now, is that a bad thing? Nah, not really. I mean, it gets the job done, right? But in order for me to make this work the way that I want it to, I would end up having to go and set up a DMVPN tunnel over this would be a second tunnel over MPLS, so that I'm not learning the routes via BGP anymore. I'm learning the routes via EIGRP, and when I do that, I'm going to prefer traffic over DMVPN and then use MPLS as a backup. That's how that would come into play. So if I lose my DMVPN tunnel, I'd still have MPLS as a backup in order to learn the routes. The routes are getting advertised, right? That's the key thing. So what I basically would need to do is set up another tunnel from here, and I need to do another tunnel here, but then I would need to do, let me draw this over on orange, make this kind of thick, and I would need to the tunnel would need to come this way, and then the traffic would route that way, so that I'd have a secondary tunnel and everybody would be happy. So right now, the way that it's sitting is that I'm going to be using BGP for these routes. Now, there's technically nothing wrong with that, right? The job gets done the way that it needs to. But if I wanted, let's say, for example, this is typically something that I would see, is customers like the fact that they're able to protect their traffic over the provider's network. You're throwing it inside of a VPN tunnel, the provider can't see anything but ESP traffic flowing back and forth. They do a Wireshark capture, encrypted ESP. That's it. A protocol 50. So, no, 51, sorry. 50 is authentication. So, with that being said, I would need to set up another tunnel. So I would configure tunnel 2 and use a different subnet and advertise my routes that way. Now, what I could do locally on this is how you would hack this, is go ahead and clear the screen. What I could do on this side here, and if I was to look at say 30 5 and do a show IP route, I'm learning everything. I'm learning 36 subnets, but you'll notice that I'm not learning 35 or 32 or 33 on 35. I'm not learning them. And there's a reason for that, because I'm not redistributing EIGRP into BGP. And that's what's happening right here. Is if we look back here, we've got BGP down this way, but we have, EIGRP over the DMVPN tunnel, right? So if we do here, we have EIGRP being learned this way. What would end up having to happen is I would have to go between the two, and I'd have to redistribute from EIGRP into BGP and BGP into EIGRP in order for any of the stuff that's being learned from via MPLS via BGP, I'd have to redistribute that into EIGRP in order for it to get propagated over the tunnel to the spokes. So this is one of the reasons why when you're getting into designs like this, it gets more complicated than just setting up a DMVPN tunnel. Maybe you only have MPLS reachability. Maybe you can only get to it via MPLS. If that happens, fine. But from a perspective of this connection right here, we're using two different routing protocols. You provide protocol separation, but then you deal with administrative distance issues. So in this case here, we're preferring EIGRP over BGP because of AD. If I was to bump the AD, and I can show you what this would look like. If I was to bump the AD on CSR31, I do a router BGP 65001 and type in distance BGP. Let's see. No, it's not this one. It's maybe it's an address family thing. Address family IPv4 unicast. Distance would be, let's say, 91, and sorry, distance BGP would be for external would be 91, and then for internal we'll say 200, and for local routes we'll say 200. And now if I do that, and then I come down to and do a show IP EIGRP topology, now you're going to, it should update that. Show IP route. I should be learning everything. Oh, it's not doing it. I may have to clear show BGP IPv4 unicast. I may have to do a clear BGP IPv4 unicast star soft. See if that's kind of weird that it's not letting me show run section BGP. I did change the distance, right? Distance BGP 91, 200, 200. Yeah, so this might take a minute for it to do its thing. Show IP route. See, these are being learned externally. These routes, and I wanted to change those. That could be a bug too. I'm not really sure. I could do the on a per neighbor basis too, but show run section BGP. And what that means is I'd go back to here. I would do this. Control A, no. Type in distance for administrative distance for would be 91 for the source address. This would be 192.168.31.42 0.0.0.0. So anything that's coming from CSR42 should get a distance of 91. So do show IP route. Yeah, that's not doing the trick either. Anyway, okay. So anyway, the point that I wanted to make here was, go and clear the screen, is we want to do DMVPN over the over MPLS. So to do that, we would need another tunnel, or what we could do is we could come over the MPLS tunnel. Well, where the transport that we use is irrelevant, right? That's irrelevant. Whether we use internet or we use MPLS, we need to make it so that the routes are being learned via EIGRP. So we could go on 35 side and do a show run pipe section BGP, and we could take these network statements out, and then the EIGRP would learn them. So we could do that, and I'm not sure if 36 is doing that as well. BGP, I am. So let me go ahead and pull them out of BGP as advertised, and then we'll just do via EIGRP. That probably would fix a lot of our problems. Let me go ahead and do that real quick. Another way would be to do a different tunnel too, but so then if I do it that way, I'll go back to 31. I should be learning 36. 36 is now coming over the DMVPN tunnel. And it's going to take a couple of minutes for all that to propagate, but once it does, we're going to start seeing, let's do a clear BGP IPv4 unicast star soft. So now all 36's subnets are coming across DMVPN. So let me go and do the same thing on 35. Sometimes the easiest way to do it is just to change the way it's getting advertised. Which in this case here it is. So clear BGP IPv4 unicast star soft. And then we're going to jump back over here to CSR 31, hit the up arrow, and we'll start seeing 35. We'll do a clear. Now everything is coming via DMVPN and not via MPLS anymore. Now, what would I have to do in order, if I did have that scenario coming into play where I wanted to have it come into play where DMVPN was preferred over BGP? And then in the event that the VPN was down, then we'd take MPLS as a backup. Well, what we could do is there's a couple ways we can do it. The first thing that pops into my head that what we do is we look for an exist or non-exist map to advertise. So if it exists in the table, if it exists, right, then we advertise. If it doesn't exist, we don't advertise. But and I don't remember, I can never remember which one goes first. And I've only played with it a couple of times just to see what the options are. But if we wanted to set up a tunnel, like if the tunnel went down for whatever reason, or internet transport failed, then we would want to go back, we'd backhaul it that way. The easier way to do that, more often than not, would be to have a second tunnel set up and then have it weighted with delay. And we'd have a secondary tunnel, but it would be sourced. And I can show you what that looks like. It's actually pretty easy to do. So we can actually spin that up pretty easily. We don't actually want to advertise the routes via BGP, right? So if I was to go back to PC66 now, and let me go ahead and get out of the way. If I was to ping 10.35.0.1. Oh, you know what? It's not going to work because I didn't redistribute EIGRP and OSPF. So let me go back over here and let me move this off to the side. So if I was to come in here, like go away. So I need to do on 31 at least, which is what I'm on. I need to go to global config, and I need to go to router EIGRP 255, and I need to type in redistribute OSPF 1, and then metric is going to be something relatively high. And then router OSPF 1 redistribute EIGRP 255 subnets. And then I need to match. No, I should be okay that way. So now that I've done that on switch 20, minimize this, scoot this over, bebop over here to 22, show IP route. I should see 1710255. These routes are now coming through, and on 35, show IP route, I should be learning a bunch of routes through, and I'm learning 10, 11. Some of these are coming in via BGP, right? And this would be the problem that we have, right? So this would be another scenario that we'd have to consider, because we would be going out. So let's see here, 31's perspective, do a show IP route. I would take DMVPN to get to this subnet right here. But then on the way back, I would, on 35, in order to get to 10.1.10, I would take BGP. Because that's the way that the DMVPN is forwarding the traffic. It's hitting here and it's taking the more specific route. So this guy's learning it via BGP. And so that's where having there's a way we've done this in the past where you would do a VRF aware DMVPN, where the underlay for both internet and for MPLS would be in a VRF. Everything would be in the global routing table. So you would do a BGP peering from the customer edge to the service provider via BGP, but then you run EIGRP. And the BGP peering to the provider would be VRF aware, and then you would do VRF aware DMVPN and EIGRP over the top of it, and then you'd be able to learn the routes over the MPLS transport. So it's kind of a weird thing. This is not going to work if I go back and test it. It's going to fail. I'm going to guarantee it, because the fact that we're doing asymmetric routing. That's funny. It's funny how I say it's going to fail and I can guarantee it, then it works. So let me give you an example of how this comes into play. So 10.35.0.1 numerically. I'm going to take DMVPN. Right? I take DMVPN right here. I hit 31. I take DMVPN. So the VPN connection gets over there, but to reverse the flow from 35 back to, if we go back to show IP, let's see, if we ping, that's going to be 10.1.10.66. Actually, then I need to source it. Sourcing it from loopback 0, I can ping it, right? If I do a trace route to that same address, I'm going to take the MPLS path. Actually, Control-Shift-6 on that real quick, numerically, because it's trying to do a lookup. I'm taking MPLS. So I go out via DMVPN, but I come back in via MPLS. So is this best practice? No. I would never keep it this way. The reason I said it would be, it wouldn't work is if this was if this traffic was sitting behind a firewall, which I have plenty of customers that do have something similar to this, where they put a firewall somewhere in between and they have the traffic go out. if the firewalling is connected to two different devices, or you're going towards the internet edge or something where there's internet termination, you pass through the firewall to hit the router, the traffic goes out, but let's say the traffic has got to come back in that same way, where that's the expected path is to come back in through the way you went out. But if I had another connection to a WAN provider through BGP and I wanted to protect it, I'd come in two different interfaces. I'd more than likely have two different zones. And so it would fail because it would be asymmetry. I'd be going out one way, coming back in another. That'd be a bad thing. And you can see I'm going out one way, coming back in another. There's no firewalls here, so it's not that big of a deal. But in the real world scenario, this would be a bad thing. You wouldn't want this to happen. Because normally what will end up happening is somewhere in the mix here, bust up my pen tool real quick. You would have switch to a lighter color. You'd have like a firewall sitting, you'd have your internet edge firewalls, right? But then you'd probably have on the WAN edge and the internet edge, I would have firewalls sitting somewhere right here or right here that's inspecting the traffic as it's coming and going. It's not every customer will do that, but the ones that are conscientious of the fact, because you might have MPLS, but you might be connecting to Azure, and or you might have a different set of firewalls, right? Going out and then you'd be coming back in. So if you went, hypothetically speaking here, if you went, go ahead and clear this off real quick and move this back over so you guys can see the spokes. Go ahead and get out of the way. If I was to do, let's say we had firewalls, a set of firewalls here, and a set of firewalls here, right? What would normally end up happening, let's say these guys are, I would have traffic, if it's one set of firewall, if it's a firewall on the WAN edge, as long as it's set up correctly, you'd be okay. But if I have traffic coming in this way, and then flowing through this firewall and coming out this way, and then jumping over here to CSR35, and then the return traffic is coming back in this way, theoretically speaking, it would work okay, right? It's assuming that you're not dealing with one big firewall or a pair of firewalls that have connections going a couple different directions. So where I have run into problems with this in the past is when you have a scenario, where's my pen? Pen is right here. A situation like this, where you've got, let me just draw it up here. Whoops. Well, that's weird. So you have connectivity up here. Well, you know what? I have a sneaking suspicion my pen tool isn't set up right. I'm able to jump. Well, no, I'm not. I'm okay. So if I have a situation here where I've got a firewall here and another firewall here, and these guys are terminating. Why that sensitivity is awfully high. And I've got the iNet edge here, and then I have another pair of firewalls here, and this is WAN, right? What'll end up happening is if I've got connectivity crisscrossed here, this guy goes to here, so on and so forth, what'll end up happening is if I have the traffic flowing through one firewall and coming in on another one, that's where it could become complicated, or you'd run into asymmetry. But if you're like this, you're probably okay. But I'm not going to go too much deeper onto that because that's not the case for us. But as you can see, it is asymmetric, but it gets the job done. So is it going to work? It does. You can see that. But am I going to take this any further? I'm probably not going to. What I could do is I could set up a DMVPN tunnel that uses MPLS as transport. I could take it a step further. Now, if I was teaching this, I would have every scenario or the majority of them laid out to where I'd say, okay, we're going to do DMVPN over the global routing table. Then I'm going to do internet VRF global MPLS. And I would do internet and MPLS peerings in the VRF, rest of the LAN side of the network, and the tunnels inside the global routing table. So you'd never run into this problem. You would be using the internet and MPLS transports in a VRF to reach the underlay out to wherever you're trying to go. But in the overlay, the tunnels would tie to the VRF enabled interfaces, but you'd have tunnels going over the top to allow the route exchange to happen and go back and forth from there. So that's essentially where that would come into play. Now, the other thing what we would want to do for redundancy is we'd want to have a second hub, and we would want to have a second tunnel going over a different transport. So you would have a tunnel going internet transport and a tunnel going MPLS transport. And this would provide you transport redundancy, but also hub redundancy. And then more often than not, you'll see in colos where there will be different sets of tunnel hubs, where you're going to peer to HQ hubs and data center hubs or colo hubs. And then there's going to be some sort of connectivity behind the scenes that you don't see, that the hubs will be able to talk to each other, whether it's a tunnel or whatever, so that anything that happens at HQ, you can fail over to the colo. So you terminate the connections, tunnels at both, but you would prefer the HQ tunnels over the colo tunnels and go from there. So like I said, there's a number of ways that you can set this up, but redundancy is the name of the game. So with that being said, I want to thank everybody for stopping by and hanging out with me. If you have any questions, comments, or you think I'm wrong, leave a comment down below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you guys in the next video.